So, good afternoon, my dear students. This is General Physics 2, Physics 21-22. Our topic today is electric current, resistance, and electromotive force. This is under week 3 of our module in the LMS. For our learning objectives, at the end of this presentation, the students will be able to describe the relationship between the electrical current, voltage, and resistance in a circuit. Second is to apply Ohm's law to circuit containing resistance and EMF. Third is to illustrate the relationship of resistivity and temperature. Fourth is to define electromotive force and electrical power. So these are our objectives of today's session. As you can see, in the left figure, we have a flowing water. Of course, flowing in a pipe to the faucet. No? So when an electrons move from one place to another, we say that there is an electric current, like in the diagram in the right side, where we have a representation of a moving electrons. So the term current probably comes from the analogy with the flow of water in a pipe. The strength of a water current depends on both the speed of water molecules and the number of water molecules involved in the flow. In a similar way, we can consider the flow of electrons in a wire. The electrons can move freely through a metal, and we will always use the term wire to refer to a metal wire. So an electric current in metal wires always consists of flow of electrons. Such currents are assumed to occur in the direction opposite to that which the electrons move. Since a positive charge going one way is for most purposes equivalent to the negative charge going the other way, so this assumption makes no practical difference. So both positive and negative charges move when a current is present in a liquid or gaseous conductor. So as you can see in another figure, we have a source of electromotive force, the battery. The line is for wire, and a device that uses current, a light bulb, and back close to the source. Now, yung pressure of, by analogy, yung pressure of the water in tank is analogous to voltage. Yung pressure, no, is again analogous to voltage. The diameter of the pipe restricts the flow of water. And this is also analogous to resistance. And at the opening, the amount of water flowing through the pipe per unit time is analogous to electric current, where an electric current is the flow of electrons per unit time, or flow of charges per unit time. So any motion of charge from one region to another is called an electric circuit or electric current I. Again, any motion of charge like water, yung kanina na figure, from one region to another is called electric current. So let us define electric current. This is amount of charge flowing through a specified area per unit time. If the charge carriers in a material have concentration N, charge Q, and drift velocity V, the current I through an area is given in the formula. So Again, the letter symbol for electric current is I, Q for charge, T for time, N is the concentration, and Q type of charge, V drift velocity. Now, so what is this drift velocity? This is the average uniform velocity acquired by free electrons inside a metal by the application of an electric field which is responsible for current through it. And of course, A is for cross-sectional area of the conductor. The SI unit of current is ampere, capital A, and this is equal to 1 coulomb per second. So 1 ampere again is equivalent to 1 coulomb per second. So we have this worded problem, an application. So a typical household light bulb requires a current of about I is equal to 0.50 ampere. If this light is turned on for 1 hour, how many electrons pass through the light bulb? Right, so all we have to do is to summarize the given quantities. What is this? This is our I, or electric current value. 1 hour is for time. We want to find electrons passing through the light bulb in the given time 1 hour. So T therefore is 1 hour, convert that to seconds. Why do we need that to convert from hour to seconds? Because the unit of I, or electric current, this is equivalent to 0.50 in coulomb per second. So dapat consistent yung units, no? And we are going to find for number of electrons. Now, recall the formula for I, where I is delta Q over delta T. To find for Q, Q is I times T. So substitute I 0.50, express the unit in coulomb per second so that ma-cancel yan dito when we multiply that by 3600. So that's why we have now 1800 coulombs. Now, hindi pa ito makapagbigay ng sagot sa required how many electrons pass. So next, we need a constant for electron. Yung constant na binigay ko sa first topic ng Physics 2 sa week 1, no? So I gave you the constant for electron, charge of a single electron, and mass of a single electron. So from the given Q, we have to multiply that by a constant. Now, so 1,800 coulomb multiplied by 1 electron has a charge of 1.6 times 10 to negative 19 coulomb. So, makancel itong coulomb and coulomb, giving us electrons. 1.1 times 10 to the power of 22 electrons. So, this is the answer of unknown in the given problem. So, when we divide I by area, this is equal to current density J. So where current density J is equal to N, Q, and V. So current is conventionally described in terms of a flow of positive charge, even when the actual charge carriers are negative or both signs. So again, current density is J equal to I over area. Electric current per square area. Now we have a voltmeter. This is used to measure electric potential difference between 2 points. Our voltmeter is an instrument used to measure voltage. Ammeter naman, on the other hand, is an instrument for measuring either direct or alternating current in amperes. If voltmeter is connected parallel, ammeter is connected series in a circuit. Next term is resistivity. This is given in a letter RHO. Rho. A material is defined by ratio of magnitudes of electric field and current density. So we learned kanina that J is equal to I over cross-sectional area A. So electric field divide J is resistivity. Now different materials have different resistivities. This is the ability to oppose the flow of charges in a circuit, or in an oppose the flow of charges. Now resistivity unit is ohm.m, ohms omega times meter. This is letter omega, unit of resistivity, times meter. Resistivity is a measure of the resistance of a given size of a specific material to electrical conduction, and may also be referred to as specific electrical resistance or volume resistivity, although these terms are less widely used. Although materials resist the flow of electrical current, some are better at conducting it than others. Resistivity is a figure that enables comparison of the way in which different materials allow to resist current flow. A perfect conductor would have zero resistivity, and a perfect insulator would have infinite resistivity. Ohm's law obeys approximately by many materials, and it states that resistivity is a constant that is independent of the value of electric field. Again, resistivity is independent of the value of electric field. We have this table of resistivities for different substances, metals, alloys, semiconductors, and insulators. So, what is the relationship between resistivity and temperature? Resistivity usually increases with temperature. For small temperature changes, this variation can be represented approximately by the formula. So resistivity at temperature T is equal to resistivity at T sub O multiplied by quantity 1 plus alpha multiplied by change in temperature. So alpha in the equation is the temperature coefficient of resistivity. This is an empirical quantity which describes the change in resistance or resistivity of a material with temperature. And T is, of course, temperature. We have a table for that. Okay, ito yung mga table of alpha for different materials. Okay, for materials that obey Ohm's law, the potential difference V across a particular sample of material is proportional to the current I through the material. So one of the most important and basic laws of electrical circuit is Ohm's law, which states that the current passing through a conductor is proportional to the voltage over resistance. So the current is proportional to the voltage over resistance, or simply V is equal to IR. So again, V is for voltage, I is electric current, and R is for resistance. Now, in terms of resistivity, length, and area, R can be solved in terms of rho L times area. From Ohm's law, we can solve for R. So R, therefore, from Ohm's law is simply V over I. You can also find resistance using the formula rho times L times area, where rho is resistivity. Again, resistivity depends on what kind of material, length ng conductor, and cross-section area of conductor. So the SI unit of resistance is ohm, OHM, again omega, Greek letter omega. 1 ohm is 1 volt over ampere. An ohmmeter is an instrument used to measure electrical resistance, ohm meter. And a resistance quantifies how strong a component opposes the flow of charge carriers, the current. Conductance naman, on the other hand, is the reciprocal of resistance. The reciprocal of resistance is conductance. So 1 over R is C, conductance. And the unit of conductance is mho. Kabaliktaran sa ohm. MHO. While ang unit ng resistance, OHM. The higher the resistance, the lower or the poorer is the conductance. Now let us answer a simple problem to illustrate the formula of, to illustrate Ohm's law. So 120 volt toaster has a resistance of 12 ohms. So what must be the minimum rating of the fuse in the electrical circuit to which the toaster is connected? So take note of the quantities given. We're given V, and we are also given R, V and R. And we are going to find for minimum rating of the fuse. That's I. No? So the rating of fuse is expressed in terms of amperes. Now, since V and R are given, find I. Ohm's law formula, V is equal to IR, therefore I is equal to V over R. The next thing to do is to substitute the given quantities V and R and use your calculator. The answer for I is 10 amperes. Meaning, the minimum rating of the fuse to be used when 120 volt toaster is connected on it is 10A. Minimum. So, meaning hindi pwedeng gagamitin yung 8, no? Lower than 10. Kasi 10 amperes ang minimum. So, what is the electric resistance of a silver wire? 1.0 m long with a diameter of 2.00 mm. If the resistivity of silver is 1.59 to the power of negative 8 ohm.m. Okay. So, you take note of our given. This gives us 1.0 m is our length ng conductor. This is, of course, resistivity. And we are given diameter of wire. So, find resistance R. Recall the other formula. Aside from Ohm's law, other formula of finding resistance is rho times L times area. Ito yung formula in finding R. Considering length, area, and type of conductor. Now, okay na, meron na tayong resistivity value kasi constant yan, bigay yan sa problem. We also have the length, but our problem now is the area. Now, from the given diameter, we need to convert diameter mm in meter. So, i-divide ninyo yung 2 by 1,000. is 1 m is 1000 mm. That's why we have 0.020. And since we need R for our formula, pi r squared para sa area, then we divide the 0.002 by 2. That's why we have R equal to 0.001 m. And the next thing is to substitute that and use your calculator to find the value of A. So the value of A is 3.14 to negative 6 m squared. I-substitute natin yan dito sa baba. This is negative 6. Okay, this is negative 8 power. Hindi yan minus 8. Sira ang PowerPoint. Okay, next. This is power negative 6. Yan. Okay, substituted na lahat. Ito area, length, resistivity. All you have to do is to use your calculator and find the answer of R. So sa inyong calculator, pindutin niyo yung 1.59 exponent negative 8 multiplied by 1 divided by 3.14 exponent negative 6. The answer is 5.06 to the power of 3. Okay, so I hope nakuha ninyo ang answer, right answer. Let us move. Okay, so we have here the resistivity temperature curve relationship. No? So the resistivity of a conductor increases with temperature. In the case of copper, the relationship between resistivity and temperature is approximately linear over a wide range of temperature. Now, the general rule, ito yung impure at saka pure copper, no? The general rule is resistivity increases with increasing temperature in conductors. Decreases with increasing temperature in insulators. And unfortunately, there is no simple mathematical function to describe this relationship. Okay, so again, generally, when you increase the temperature, resistivity, and resistance also would increase. No? As you can see na magkapareho la ito as affected by temperature change. Okay, so we have this simple problem to illustrate the relationship between resistance and temperature. So a platinum resistance thermometer uses the change in R to measure temperature. Suppose RO is 50 ohms at temperature 20 Celsius. Alpha is given. What is R when T is equal to 50 degrees Celsius? Now, i-summarize lahat ninyo yung given. And the unknown is R when T is 50. So next is to use the formula R of T is equal to R sub O multiplied by the quantity 1 plus alpha multiplied by change in T. So plug in lang lahat yung given. And of course, even hindi pa natin ito na ma-compute, yung makuha yung correct answer, ma-expect na natin na there is increase in resistance because the temperature is increased from 20 to 50. So using your calculator, R is 55.9. That shows that R is affected with the increase in temperature. Now we have this a complete circuit. No? A complete circuit is a conducting loop that provides a continuous current carrying path. Carrying a steady current must contain a source of electromotive force, EMF. Now in the figure, we see the water flows from higher to lower potential energy. So yung water flows from higher to lower potential energy. As the water moves in the direction of this decreasing potential energy as the direction of gravitational force. Now, how to bring, since decorative, this is not natural, no? Decorative or artificial, how to bring this water back on top to obtain a continuous flow of water. So in this case, that is why we need a device, a pump, so again, a device is needed to bring water back on top. So that is similar in an electric circuit, wherein electrons move from higher to lower potential. Now, how to bring the electrons back to the location with higher potential energy and to have a continuous flow of charge in circuit. So we also have a device like a pump in waterfalls, a device for in a circuit that is called EMF, source of electromotive force. No? So this is like a pump, EMF. So what is the difference of potential difference and electromotive force? They have the same unit, volts. So voltage is the potential difference between 2 points which causes current to flow. It is the amount of energy per unit charge while moving between 2 points. While an EMF or electromotive force is the amount of energy supplied to that charge by battery cell or other source of electromotive force. Again, a complete circuit should contain a source of EMF. The purpose is to bring the electrons back from lower potential energy to higher potential energy, like in our artificial waterfalls. For example of sources of EMF, we have the battery, solar panel, also have the solar wind, no? Okay. As a unit of EMF is volt, the ideal source of EMF maintains a constant potential difference, independent of current through the device, but every real source, kasi sa ideal source of EMF, V is equal to EMF, no? But in real source, where real source contains an internal resistance R, then our terminal voltage, therefore, is equal to EMF minus potential drop I times R. This is due to internal resistance mod R. So this is the formula on how to solve for the terminal voltage having an internal resistance. So next is electrical power or electric power. The rate at which work is done to maintain an electric current is given by the product of the current I and potential difference V. Simply power is VAB times I, electrical power. Now, kung ma-recall niyo yung power formula sa General Physics 1, power is equal to energy or work per unit time. Work over time. Now, ano ang unit ng work? SI unit is J, where J is joules. Time in seconds. Seconds. Now, dito naman sa electrical power, let us see kung ano ang unit dito. So, the unit of V is joules per second. Volt is equivalent to J over S. And when we multiply that by the unit of I, where the unit of I is ampere, where ampere is equivalent to coulomb. Is that coulomb per second? No, this is joule per coulomb. By the way, V, volt, is J over C. Okay, this is C. And unit for I is coulomb per second. So when we multiply, the units of P is J over S. And J over S is equivalent to, or 1 J over S is equivalent to 1 watt. So yung unit ng power, therefore, is watt. No? So kung usually naka-express in kilowatt, megawatt. So 1 kilowatt is 1,000 watts. 1 megawatt is 1 times 10 to the power of 6 watts. Now, our resistor R always takes electrical energy out of the circuit, converting it in the form of heat, thermal energy. So we can find the power dissipated by the resistor in this formula, V times I squared times R, V squared over R. So depende kung ano ang given, no? Values, you can find the electrical power in terms of V, I, and R. A wattmeter is an instrument for measuring the electric power or the supply rate of electrical energy in watts of a given circuit. So we have the application of what we have discussed in the previous slides. So a generator has an EMF or electromotive force of 120 volts and an internal resistance of 0.20 ohm. Letter A, how much current does the generator supply when the terminal voltage is 115 volt? So again, we are given an EMF and the VAB. Recall yung formula, relationship ng EMF and terminal voltage. Ito. So to solve for I is EMF minus terminal voltage divided by R. So you have to do is to substitute 120 minus 115 equal divided by 0.2. So the answer is 25A. So next is how much power does it supply? So simply P is equal to I times V or V times I. Then I is 25. VAB, use VAB because 5 volt yung nag-potential drop due to internal resistance R. So our power therefore is 2,875 watts or 2.875 kilowatts. Okay, so may mga review questions tayo. What is the resistance if the current is 2A and voltage is 10 volts? Five ohm, very good. So simply, you divided 10 by 2. From the formula, V is equal to IR, V is equal to I times R, then R ang unknown, R is equal to V over I. Next. Give the unit of the following. Letter A, capacitance. Ano ang unit ng capacitance? Unit ng capacitance, recall. Recall din yung week 3 man yata yan. Ano ba yung unit ng capacitance? Unit of capacitance is farad. Capital F. What about unit of electric current? Unit ng electric current is ampere. Correct. Okay. Unit ng resistance, based on what we have discussed. Yes, very good. Galing. What about unit of potential? This is week, actually, capacitance week 4, week 3 yata itong potential. Correct. Volt. Ha? Okay. Unit na charge. Coulomb. Very good. Or capital C. What about electric power? Okay, that's it. Correct. Galing-galing ninyo, class. Okay, so we have another review question. What instrument is used to measure potential difference in a circuit?